So hello everyone, welcome to this week's PR review club. So today we'll be reviewing PR coin 4, it is 33231, which titles net prevent node from binding to the same C service. So I guess it's pretty clear from the title as well. Binding, which means like the node uh, would listen to an incoming connection. Okay, to an incoming connection, it will bind to that port. So the peers that your node is or the peers that will try to connect you should like connect to this port, or else they won't be able to connect. I mean, your node listens to this port. So that's the binding. And CService, it's actually a class in Bitcoin Core that uh, it's a class in Bitcoin Core which does stuff with the network address. Okay, and it's derived from the CNET address, which is also a class, basically a data structure uh, that stores or represents the IP address, IPv4, IPv6. Okay, and going back to this PR. So speaking about the PR, what this PR does, it's previously the node would, if you supply multiple bind of, then the node is like it's stopped with some misleading messages. Okay, this kind of messages. But actually, what should happen was, if we supply multiple bind options or arguments of the same address, then it should listen to this to that address. Okay, but it wasn't listening, and it was stopping with some misleading messages. So let's see that. I am I guess running Bitcoin, yeah, version 29.0, and I've also, so if we run, yeah, so if we run with same bind address, then this will probably crash. Not probably, but this will crash. Yeah, and it will crash, and it will show this some misleading messages. Okay, unable to bind to 0.0.07060. I mean, this should be bind, because shouldn't matter like if you supply multiple bind, multiple similar bind address. Okay, so that was the issue, and with this PR 33231, which just got merged. I mean, 2 days ago. I created. I thought that this will be merged after this PR review club, but this was merged. I mean, the Vasil and Vasil, John Attack, and SIPA, they actually did act very quickly, and it was merged. So yeah. So this PR proposes that repeated bind options will have no effect. So before going to this PR code, let us see how it crashes. Okay. So this is init.cpp. Whenever you start your Bitcoin D or Bitcoin code, this is the file which gets executed. I mean, this is the main part, and all other are the, like, it's the sub part of this code. Okay. So in this line, line 1933, we have a for loop, which what it does, it's takes a bind argument string, okay, pointer to bind argument, and it will take the argument bind. If you supply with hyphen bind, then this will take all the like string after that, this argument. Okay, this will exclude this is equals to, because we're not interested in that is equals to. We're just interested in the IP address and the port number. So after that, a lookup will call, which will look whether that address it's actually possible. Possible, it means that Suppose there is another service running in your computer, for example, Prometheus, okay, which runs in port 8080. So if you try to bind in that port, this will crash. So how it crash? This function does that thing. Okay. So yeah, after that, what happens is we have a con options, which is basically, yeah, conman and options. Okay, this will store all the IP addresses. So so if you supply with bind argument, then it is stored inside this object, and this one is a vector. So it will store this value. Okay. So if you supply two arguments, because this is a for loop, so if we supply two bind arguments, then because con options or vbinds, they are actually vector, so they can store. Okay, this is not a set, so this will basically store all the multiple IP address. Okay, so this will store, and what happens is when multiple address is stored, um, probably there is yeah, this is the if else if condition where we have node, and node it's actually node context, and this will start the service, and this is inside the net.cpp. Yeah, inside the net.cpp, and we'll supply the scheduler. It's actually a she scheduler, or it's basically a class. Like if you want something to be scheduled for later, then we use this scheduler object, and we supply con options as well. Con options contains all the binds, white binds and onion binds as well. So sorry, I forgot to tell you that white binds and binds, they're actually different. White binds is actually uh, similar to bind. What it does, it's actually opens, not open support. It connects to that node. Okay, for example, there is another node running somewhere, and it has some IP address and port. Okay, so if you supply white bind minus white bind hyphen white bind, okay, then what happens is it will mark that node as whitelist. And what whitelist? It's like you trust that peer. Like if that peer is misbehaving, it won't get disconnected. So that's the idea about whitelisting the peer. Okay. So con options contains all of this. If you supply bind, if you supply white bind, if you supply onion bind, it's basically same as bind. The only difference is that if you're running a TOR, then it will listen to that onion address. Okay. So yeah, so this will call the start function, which is inside the net.cpp. Net.cpp, it's actually another big chunk of file or code which does all the networking stuff in Bitcoin code. Okay. There's a function start, takes the argument at sheet scheduler and options. Okay. So here, if you see, then we should have a check. Yeah, let's see. Yeah, there's the check. So check this calls another function which is bind, and what it does, it's again calling bind, and this will throw if, like, if we are not able to bind to that address. Okay, so this happens when we have multiple bind options, or basically we have similar binding IP address, okay, inside the object, or basically con options. Okay. So that was the main issue, and this PR tries to solve that. Not tries, but it actually solves that. So let's go to commit. So, yeah, let's read this commit message. So currently, if a user inadvertently starts the node with duplicate bind options such as bind 0.0.0 and bind 0.0, these are multiple or duplicate bind IP address. It will cause a fatal error with misleading messages. Bitcoin Core is probably already running because when this bind is called, it actually already connects to that port. Okay. So again, if this bind is called again, and when it tries to connect to that uh, listening address or that port, it will fail. Okay. So this will fail, and because of that, we just stop the node. Okay. So bc log net, and then we'll just log that unable to bind to this address, and then return false. And if we return false, then this won't be possible because we have this if condition. Or basically, this also returns false. If this one is false, this one is also false. Um, so what this PR does is actually it adds an early validation to detect duplicate bindings across all binding configuration. Okay, bind, white bind, and unend bindings. Okay. So before attempting to bind when duplicates are detected, the node terminates with a clear specific error message. Okay. The node terminates. Okay. Um, Message with duplicate binding configuration. Please check your bind and whitelist binding address. So it won't give some misleading address that Bitcoin core is already running, but it will terminate with some uh, user. I mean, good messages. Okay. So with this message, not some misleading messages. So this is actually the part, the check part, or you can say validation function. Yeah. So let's just pull this PR. Just build this so that we'll just go through this through the commit and later run this. So yeah, coming back to commit. In the first part, it's actually a Doxygen style comment. And then we have a validation function uh, with the return code as CService and check binding conflicts. Okay. So CService, we have just used set. So as we can see, we are not using vector, we are using set. And if you know, then set, it's actually, it doesn't store the duplicate value. Okay. So first we'll check all the whitelist bindings. Then if that scene, if we insert a duplicate one, then it won't store. Okay. So this check does that. And then we do for the regular bindings. And if we have seen, or if we have seen, if you have already seen this value, then it won't store. Okay. And then we'll check the onion bindings. Um, yeah. So similar goes for onion binding, like if this, I mean, if this onion address is seen already, then we won't store. We'll just return the previous onion bind. Okay. So yeah, so we are returning this. If all this is fail, then we'll just returning null out. Okay. That means, I mean, this. there was some error, or basically you can say exception in this validation function. So now we have in line number 2179, we have this check, is if auto conflict is equal to check binding and con options. We are supplying the con options, and then if that is false, then we'll just return init error, okay, with this message. And also we give the conflict the two string added support. Okay. So if you see the code part, yeah. So there is the check and check binding conflicts. It's actually validation function. We're passing the con options. Okay. Then after this check, if this succeeds, then only this one is uh, run, or else this won't be executed. Okay. We've already seen this is the main part for like checking whether that bind is available or not, or basically checking the duplicate bindings and stopping the code. So yeah, if we see commit message or the commit, and we'll talk about this. For now, let's try to run multiple binds. Yeah. So see, you can see the node shuts down, but you won't be getting any misleading messages. Like we supply duplicate binding configuration for address 8333. Check your this. So like this, we'll be getting some uh, user-friendly message, okay, instead of some misleading message. So if you try to submit different port, so now what happens is your node will be listening to port 6060 and 7080 as well. So if we have like a different uh, port number, then this will definitely like execute, and your node start receiving the blocks, or basically start connecting to all the peers from the DNS. Stop for now. And so the next is functional test. If you are changing a code, or basically if you're getting some bug, and if that's not detected by the functional test, and you are actually fixing that bug, then you should also add the functional test. So here what we are doing is first we are stopping the node, or basically cleaning up all the previous test, because we want this test to be run with fresh. Okay. So we are giving this address. Okay. Port is 11012, and we're using this function combinations with replacement. What happens? This is will actually uh, see all the like options, okay, strings, or basically you can say options, and it will take out of this three, it will take two. Okay, I mean it will take combinations of two. So it's like out of three, how many combinations are there by taking two. Okay, so that's the idea with the idea behind this function combination with replacement. And then after we have got this combination, or basically opt1, opt2, will be asserting that with the nodes. I mean, supplying that bind options, because we are supplying this bind, and we supply this bind option and check whether this functional test is passed or not. So if you use this functional test for the Bitcoin Core version 29.0, then this will probably fail. Not probably, but this will actually fail. And with this fix, this will not fail because we have already fixed the bug. So in this PR, there was some interesting thing that Loring, he actually, like while running this PR, he actually got a another bug, or we can say, I mean, not bug, but like error, you can say. His node was actually not stopping. I mean, when he was doing IBTs, for example, if you're doing IBT, initial block download, you're starting a node from scratch, then your node would, if you supply multiple bind option, first of all, that would crash. And if you again run that node, then your node won't crash. I mean, it will download all the blocks. And that was the thing, or basically observation by him. This is the open issue. So what happens was init error, it's actually a function, is triggered during initialization. Okay. So when there is a multiple bind options, this init error is triggered and the node stops. Okay. Node prints error, but sometimes continues running if blockchain data already exists in the data directory. So for example, if there is already a blockchain data, the node prints the error, but it actually runs. Okay. Yeah. It actually runs for some time, but yeah, you can see. Yeah, as we can see here, it the node starts and it updates the tip. Okay, and then it stops. I mean, this should have stopped early, but it's not actually stopping. So I actually did dug into this issue and actually found that it wasn't updating. I mean, for example, you're running your node. Okay, you're running a node with not multiple bind options, with a single bind option, or basically in a default way, you're running a node. Download some blocks. Okay, so let's run this. Let's try to run this. Uh, I've already built, and we'll just uh, right. Yeah. So this will start, and it will download all the blocks up till 100 blocks, and after that, this node will stop. Okay, this will probably take a lot of time. I mean, we'll synchronize. We're pre-synchronizing block headers, then we'll synchronize the block header. Yeah, we'll see that. So the issue, when I dug into that, I found that when we are running node like this by default, then what happens is it downloads all the blocks. I've used the stop height as 100, but what happens is it stops the validation at 100. I mean, it has downloaded all the blocks, not all the blocks, but it has downloaded blocks more than 100. But with this argument, the stop height, what it will do is it will stop the validation up till the block height 100. Okay. It won't validate further, but there are down blocks that has been downloaded because in Bitcoin Core, currently we use compact blocks relay. So compact blocks relay, if you see, then you can't have some limit in that compact blocks message, P2P message. But with this argument, what it does, it's actually stops validation up till 100, but the node has already downloaded more than 100 blocks. So when we start again, the node has stopped. When we start the node again with multiple bind options or basically invalid uh, address or argument. As you can see, he have used some invalid argument, and it should probably crash. It will definitely crash, but what happens is this is actually validating, and it is validating because are we have already downloaded all the blocks, and Bitcoin Core, it validates all the blocks or data directory. Uh, After that, it starts the node. Okay, because it why this is done, because Bitcoin Core, it actually like syncs with your recent data directly. Okay, and that's why we have seen this message update tip new best chain, and if you see the height is more than 1,000 XPs. Yeah, more than 1,000. So previously it stopped validation until 1,000, and now we haven't validated this block 1,001, so it starts validating this block. Yeah. See, the next execution, he hasn't used this stop height argument. So what happens is, first the node will validate all the blocks present in the data directory, then it stops because we have supplied the invalid argument. That was the issue, and not sure we'll try to fix that or not. Martin actually he says that like we won't. I mean, it's not beneficial like if we to write a check before that. So it's not beneficial. I am pretty sure this won't be like there won't be any PR for that. It might be, but I don't think so. Uh, like all the developers are interested in that. So what he says is that it's true and could be unexpected that init load may do some work connecting blocks before that, but there is a downside to that. It's not possible to simply delay the init load start without other changes because init load also connects the Genesis block, which we wait here. I think I think to avoid clients like the GUI from crashing that assume a chain exits. Yeah. So that's what I said. Like we can't change the init load. We can't change the uh, execution of the init load. Like we what Loring's proposed is that we want that init load should be before the validation function. So the issue is that it will crash the GUI, which assumes that there is already a chain. Okay. So yeah. So when we try, so now we can see we have the updated height 100. Okay, but this is actually the validation stopped till 100 height, but there are blocks that has already been downloaded from the peers, and that's not validated. Okay, so if we run, uh, mm, then you can see this should probably validate all the downloaded blocks. Just use what is used. We'll just download more blocks. Okay. So yeah, so now we are downloading the blocks. Uh, Now we'll use this invalid argument. So now you can see that it should crash. I mean, already this should be crashing, but we can see the Bitcoin core, it actually validates all the blocks or chain state that has been present in the data directory that has been downloaded but not validated. So now we can see we have verified this height 1002 and 1003 and all that. So that means that we have downloaded up till 1037, although we have given the argument as stop height 1000, which means that we have downloaded more than 1000 blocks. Okay. So that was the issue, or basically idea behind this issue created by logging. Um, yeah, we can just run this test. So this will probably like it won't crash. This will probably run. So if you see, then we have first we have used this bind option, and then second we have used this combination. Okay, and third we have used this one, and you can see that we are only printing this one because there might be multiple we're using this one again, so it's not, I mean, like it's not informative to print again this one, but actually we are using this bind argument multiple times, I mean two times. Okay, so we have probably 6 combinations. Okay, yeah, so this test also succeeds, and this one is the check for that test. Yeah, that's it. See if we have. mm, Previously, before this reviews, this PR actually had uh, like it wasn't stopping. It was actually running, but like it wasn't stopping. I mean, it was running if you supply multiple same bind options. But actually, that wasn't uh, the way. Like some developers such as John Attack and Vasil, they actually said that it's not good to keep running the Bitcoin node. We should actually stop that node and give some informative message, okay, so that user can debug that. And yeah. So that was it. And we can go with the question. So let's go to the first question. What does bind argument do in Bitcoin Core? Anyone wants to give it a shot?
They just bind the port with some address.
Yeah. And your node actually binds to the address so that all the P2P connections can listen to that. And the next is currently in Bitcoin Core, what happens when we supply multiple buying options? Currently means before this PR got merged.
So it will crash with some unknown message.
Yeah,
But after
correct.
this PR, this will fixed by mean. It will show some proper message so the user can understand what is going wrong and he can fix.
Yep, correct. The next is what is the role of CService?
I think it's related to IPv4 and IPv6, as you said, if I'm not wrong.
Yeah, correct. Uh, I
Okay.
mean, it's actually a class, and it will do. You can do all the stuffs with that IP address, IPv4 and IPv6.
Yeah.
Uh, so this was it.